Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of a stationary random process. The example is a random process is defined as x of t is equal a sine of omega t plus theta, where a is a constant and theta is a random variable uniformly distributed over minus pi comma pi. Check x of t for stationary. Coming to the solution, given that the random process x of t is equal a sine of omega t plus theta. So now here capital A and omega are the constants and theta is a uniformly distributed random variable over the interval minus pi comma pi. So we know that the standard expression of the probability density function of the random variable is 1 by b minus a over a to b. So using that standard expression, now here we can determine uniform density function of the random variable theta over the interval minus pi comma pi. So f of theta is equal 1 by pi minus of minus pi. So 1 by pi minus of minus pi is 1 by 2 pi over minus pi to pi. So this is the probability density function of uniform random variable theta. So we know first calculate the mean value of the random process x of t. We know that the expected value of the random process x of t expression is expectation of x of t is equal integral minus infinity to infinity x of t into fx of x dx. So now here expectation of x of t is equal theta is the random variable, so integral minus infinity to infinity x of t into f of theta d theta. So now applying the given data, expectation of x of t is equal, so the range of the theta from the given data is minus pi to pi. So given that the random process x of t is a sine of omega t plus theta and probability density function of the random variable theta is 1 by 2 pi into d theta. So now we are integrating with respect to theta. A by 2 pi is constant, that is written before integration. So therefore expectation of x of t is equal a by 2 pi integral minus pi to pi sine of omega t plus theta into d theta. Integral sine of omega t plus theta is minus cos of omega t plus theta over minus pi to pi. Now substitute upper value of theta and lower value of theta, we get now your minus is there, minus of a by 2 pi into cos of omega t plus pi, and this is the upper value of theta, minus sine of omega t minus pi, lower value of theta is minus pi. So now here cos of omega t minus pi is written as cos of minus of pi minus omega t. So cos of minus theta, cos theta. So cos of omega t minus pi is also written as cos of pi minus omega t. So we know that cos of pi plus omega t is minus cos omega t, and cos of pi minus omega t is minus cos omega t. So now here before minus is there, minus into minus plus, so plus cos omega t. So now here minus cos omega t plus cos omega t is cancelled. So this within the bracket term is 0. Minus a by 2 pi into 0 is equal to 0. So which is equal to constant value. So the mean of the random process is constant. The first condition is satisfied. The mean of the random process must be constant. Now here the mean of the random process is independent of time t. Hence the given process is a stationary random process. Next check it, the autocorrelation function is a stationary or not. So we know that the autocorrelation function of the random process x of t is given by Rx of tau is equal expectation of x of t into x of t plus tau. Given that x of t is a cos of omega t and x of t plus tau is a cos of omega t plus omega tau plus theta. Substitute x of t value and x of t plus tau value here. So therefore RHS term is expectation of a sine of omega t into a sine of omega t plus omega tau plus theta. So a into a square Rx x of tau is equal a square is constant, that is written before expectation. So now here 2 sin A, 2 sin A sin B. So in the numerator term 2 is the missing. So multiplying numerator and denominator by 2, we have A square by 2 into expectation of 2 sin of omega t plus theta sin of omega t plus omega tau plus theta. So this within the bracket term is the 2 sin A sin B. So the expression of the 2 sin A sin B is cos of A minus B minus cos of A plus B. So this is the A value, this is the B value. So which is equal A square by 2 into expectation of cos of A minus B. Omega t plus theta minus, so multiplying minus within the bracket term, minus omega t minus omega tau minus theta minus cos of A plus B. Cos of omega t plus theta plus omega t plus omega tau plus theta. So now here minus theta plus theta is cancelled, minus omega tau plus omega tau is cancelled, and the first term is cos of minus omega tau. So cos of minus omega tau is cos omega tau, and the second term omega t plus omega t to omega t theta plus theta to theta. So therefore Rx of tau is equal A square by 2 into expectation of cos of omega tau minus cos of 2 omega t plus omega tau plus 2 theta. So now applying the expectation into each term, A square by 2 into expectation of cos of omega tau minus A square by 2 into expectation of cos of 2 omega t plus omega tau plus 2 theta. So using expectation of x of t expression, so the first term of expectation of cos omega tau is A square by 2 integral minus pi to pi. Now where the function is cos of omega tau and density function is 1 by 2 pi into d theta minus A square by 2, and the expectation of this function is integral minus pi to pi this function cos of 2 omega t plus omega tau plus 2 theta into 1 by 2 pi density function. Density function is 1 by 2 pi. So 1 by 2 pi into d theta. So now we are in first integral term cos. Now we are integrating with respect to theta. Cos of omega tau into 1 by 2 pi is constant, that is written before integration. Here also in the second term, integrating with respect to theta. So 1 by 2 pi is constant, that is written before integration. So which is equal Rx of tau is equal A square by 2 into cos of omega tau 1 by 2 pi integral 1 d theta is theta over minus pi to pi minus A square by 2 into 1 by 2 pi 1 by 2 pi. So now here in the first term substitute upper value of theta and lower value of theta. After substituting upper value of theta and lower value of the theta in the first term, pi minus of minus pi, and similarly in the second term substitute upper value of theta and lower value of theta, we have sin of 2 omega t plus omega tau plus 2 pi minus sin of 2 omega t plus omega tau minus 2 pi. So minus into minus plus pi 2 pi, and numerator and denominator 1 by 2 numerator and denominator 2 pi is the cancel in the first term. A square by 2 into cos of omega tau 1 by 2 pi into 2 pi minus A square by 2 4 A square by 4 into 1 by A square by 4 into 1 by 2 pi sin of 2 pi plus 2 omega t plus omega tau is sin of 2 omega t plus omega tau plus 2 pi is the sin of 2 omega t plus omega tau minus sin of 2 omega t plus omega tau minus 2 pi is okay. So now here take the common minus sin, now we sin of 2 omega t plus omega tau minus 2 pi, here take the common minus sin of minus theta is minus sin theta, before minus is there, minus into minus plus, so sin of 2 pi minus of 2 omega t plus omega tau. So sine of 2 pi minus of this term is minus sine of 2 omega t plus omega tau. Now here before plus is there, plus into minus, minus. So that is equal. So minus sine of 2 omega t plus omega tau. This is the plus term and this is the minus term. So plus term minus term is cancelled. Therefore, this within the bracket term is 0. Therefore, Rxx of tau is equal to a square by 2 into cos of omega tau. So now here the autocorrelation function of the random process is depends on the tau. So now the condition is satisfied. Therefore, hence the given random process x of t is a stationary random process.